this video, I'll talk about the standard normal distribution. This is a very, very important distribution, and it's important to understand this. It's the foundation of statistics. Remember, the reason for this channel is to help you pass your math class so you can achieve your goals and get a better life. Standard normal distribution coming right up. If a satellite crashes at a random point on the Earth, what is the probability it will crash on land and not on water? Since only 27.5% of the surface of the Earth is covered in land, the probability that the satellite would fall onto the Earth and hit land is 0.275, and that's just 27.5% written as a decimal. Notice if we add up the surface area of the land and the surface area of the water or the ocean, it's 100%. And if we add up the decimals, of course, that's 1. So all of the area of the Earth adds up to 1 or 100%. A continuous random variable has a uniform distribution if the values are spread evenly over a range of possibilities. In our example, it's waiting for a bus. So a person's waiting for a bus and the wait time is uniformly distributed. It's anywhere between 0 minutes and 15 minutes. It could be as long as 15 minutes. The probability space or the probability distribution is shown in our graph. Now, the height is 1/15 and the length is 15. So the area of the probability distribution is always going to add up to 1. And so the area is the height, 1/15, multiplied by the length, 15, and 1/15 times 15 is 1. So that's always the case for all probability distributions. The entire area under the curve, and we call this line here the curve, is 1. There's a correspondence between area and probability. Area and probability and relative frequency are all. So what is the probability of waiting more than 10 minutes for the bus, given that we have this uniform distribution? So what I have to do then is I've got to find this area, and this is the area, greater than 10 minutes. So the longest I would ever have to wait is 15. So between 10 and 15, this length right here is going to be 5, isn't it? And this height right here is going to be 1/15. So the probability that I would have to wait more than 10 minutes is the area that I have shown you there. So it is the height, 1/15, multiplied by 5. I can actually just put that in my calculator if you like. I'm going to get 5/15. And when I simplify that, that's just going to give me 1/3. Most of the phenomena that we will consider have a normal distribution, and this is a special case of a normal distribution, the standard normal distribution. And this distribution has a mean here shown in the middle of 0. Something you cannot see on the graph is the standard deviation, lowercase sigma equals 1, and the area under the curve. So the area in this blue right here, everything in this blue, if I add all of this up, this area in total sums to 1, and that is the probability we find by taking or finding areas under the curve. Now, this requires calculus to find the area under a curve. Luckily for us, we have a calculator that we can use to do this for us, so we don't have to learn calculus. Yay! We want to get a couple of definitions out of the way here. So a z-score is a value along the horizontal scale. So let's call this the lower z-score. It's because it's below the mean. Let's call this one here the upper z-score, so they'll just both be numbers. And when I'm finding probability, I'm going to have to find the area between the two, or it could be the upper probability or the lower probability. So let's suppose I'm interested in finding the probability between the upper and the lower. I'm going to have to find this area that I'm shading in here under the curve. And I refer to this shaded region as the area under the curve, or the region. And this we need calculus for, to find this area. But we will use our calculator to do this. A bone mineral density test helps to determine the presence of osteoporosis, and the result is a z-score. So we want to find out the percentage of the population tested that has osteoporosis, and a score of -2.5 or below shows osteoporosis. Between -2.5 and -1 is osteopenia, the beginning of brittle bones, but not yet, and anything -1 and above is normal. In order to work this problem, I'm going to have to find the probability that z is less than -2.5. Now remember, the mean right here is right in the middle at 0. So let's say -2.5 is right here. So that's my z-score is -2.5. And I've got to find this area under the curve here, everything that is less than 2.5. And I'm going to have to do that by using my calculator. The first thing I want to do is hit second distribution. Then I'm going to scroll down 1 and choose the normal CDF. Hit enter. Now down this end, I have to have negative infinity, and I've got to have a way to put that in the calculator. So that is -1 second EE, and then I'm going to put 99. So that's the equivalent of negative infinity. Then I'm going to come down here to my upper bound, which is -2.5. Remember that in a standard normal distribution, the mean is 0. The sigma, or the standard deviation, is 1, so that's all correct. I'm going to hit paste and hit enter, and that's going to put it on my home screen. Hit enter a second time, and I see that that value from my calculator is 0.0062. It's usual to round this off to 4 decimal places. So there's my decimal place. Now if I want to turn this into a percentage, I'm going to have to multiply it by 100. So when I multiply that by 100, I just click multiply by 100. The percentage then is 0.62%. So less than 1% of those tested will have osteoporosis. Next, I want to find the probability or the chance that a randomly selected person tests in the normal range. So this is the probability that they test higher than -1. So the z-score has to be higher than -1. Now down this end is plus infinity. That's my z-score really effectively. And at this point, let's just make this one -1. And so what I'm going to need to find is, I'll assume that's a straight line. I'm going to need to find this area under the curve here. And that area will give me the probability that they test in the normal range. In other words, their test score is greater than -1. It could be any value greater than -1. So I want to do second distribution, go down to normal CDF, and now my lowest amount, or my lowest score, is -1. I have to hit this key for negative, can't hit the minus key. Now I've got to put in effectively positive infinity, so this is +1 second EE 99, actually just a very large number that we use instead of infinity. Leave the mean as 0, the standard deviation as 1, hit enter twice, and that gives me my probability, which is 0.8413. You might say that the probability a person randomly selected tests in the normal range is about 84% when I change the 0.84 to a percent. In the last example here, we want to find the probability or the chance that a randomly selected person tests positively for osteopenia. That means the test score is between -2.5 and -1. So I need to find the probability that the z-score is between -2.5 and -1. And if I draw this on the graph, this is -2.5. Let's make this -1 right here. And I'll need to find this area. That'll give me the probability. Let's do that on the calculator. Second distribution, choose normal CDF. And now the lowest amount will be -2.5. The highest will be -1. Leave everything else the same, mean of 0, standard deviation of 1, and hit enter twice. And I see there that this probability, rounded to 4 decimal places, is 0.1524. So this area right here, if I write it as a percent, it's a little bit more than 15%. So I've got about a 15% chance, or 0.1524 chance of testing positively for osteopenia. To recap, if I'm looking for a probability that's less than a certain value, I want to draw my probability or my normal distribution table here, and that will be A, everything is less than the z value here, z equals A. Don't confuse the probability. The probability is the same as this area, which is shaded in black, and the z-score is the amount along the horizontal axis. If I'm looking at a right-tailed test, on the other hand, that's when I'm looking for a probability greater than some value or other. So in this case, the z-score here is B, and the probability is the area under the curve above the z-score of B. And finally, I might be looking for a probability between two values, a lower z-score of A and an upper z-score of B, in which case this is the area under the curve, or the probability. Same as the area, and we find those by using our calculator, which means we don't have to learn calculus, so we can find those areas. So the key idea here is when we're using a standard normal distribution, we need to be able to find these areas under the curve. We should write out the probability with a less than, a greater than, or both, and draw a diagram, and then use the calculator to find the area or the probability. I would like to invite you to like this video and subscribe to this channel. Thanks very much for listening.